Hi everyone, in this video our research team will present the topic of API parameter recommendation based on language model and program analysis. Our presentation is divided into 4 sections: the problem statement, our methods, the experiment and evaluation, and finally the conclusion. Section 1. Coding recommendations are frequently used by programmers and so many companies because the great benefits of the tool. They can speed up and reduce development time, minimize unnecessary error, and the tools themselves can be used to review shortcut. So, what is the goal of this problem? In other words, what do programmers need? First, the suggestion must be valid in terms of the syntax of the programming language and semantic suitability. The second goal is that the suggestion need to be sorted by the higher probability of accuracy, which means that suggestion in the top position is the suggestion programmer needs. Section 2. So, to achieve the above two goals, we propose an effective solution. First, we analyze the program to find the suggestion with suitable syntax and semantic. Then, we use the language model and shortcode feature to rank the suggestion. The overall process is as follows. The first step is program analysis to extract the necessary information of the current program. After that, we generate syntactically and semantically correct expression for the suggestion. The shortcode is represented in an intermediate form of code which is called Excode. I will talk about Excode last. The last step is to rank the suggestion using language model. Let's get into detail for each step. First, to analyze the program, we need to identify the methods that need suggestion. Be aware that in Java programming language, method overloading may occur when there exist two or more method declared with the same name. So, we need to consider the context, such as the left side of the assignment. To choose appropriate methods, this is unprecedented in previous study, in which users had to choose the methods themselves. Next, we find out the variables that are valid in terms of syntax and semantic in all input case of the program. So, that using the variable would encode any error by using data flow graph. For example, the variable x2 is declared only in this if statement. Finally, from the defined variable, we generate zero expression. For example, the input parameter type in. We have following candidates in the slide. Next, the expressions are converted to Excode and fit into language model. Let's understand Excode and its advantage. Excode is a way to represent shortcode. It overcomes the advantage of the token representation that does not carry semantic information. That means For a language model that can simply learn cotoken to guess the next token, it is prone to syntax and semantic error. Compared to cotoken, it could store additional information, such as token type and data type information, to help the language model predict more. Along with that, it could also remove variable name in order to represent the source code in an abstract level. Thus, many source code expressions will have the same Excode representation as they have the same data type. After program analysis step, we obtain the context along with a list of valid expressions in source code and Excode representation. Then language model for Excode will receive the Excode context and the Excode expression as an input. It will output the probability of expression occurring after the Excode context. The language model for the source code it had a similar function but different input. After modeling, the output will be combined with program feature to rank candidate. The program feature visual is the similarity of the parameter and argument. The idea here is that when programmers write methods, they often name parameters with a certain meaning. To verify this, we have done static under 1000 most popular Java projects on GitHub. The result shows that the similarity between the parameter and argument is considered at either 0 or 1, which means completely unrelated or completely similar. By applying the rule, the prediction performed will increase. In fact, we use similarity as a ranking factor. Finally, in the last step in process, we compile probability of the expression produced by language model and similarity for argument and parameter. Then, the expression will be with the highest score are selected and put in the list of succession. Section 3. To demonstrate the effectiveness of our methods, we compare its performance with the path, the state of the act methods to recommendation parameter. Path work by querying the API using the temple in a preview database. We perform the test on two projects, Eclipse and NetBeans. They are large projects with more than 30 million lines of code. For Eclipse, we test the SWT API. For NetBeans, we test the AWT and Swing API. The result is as shown on the slide. In addition to compare with Prague, we also perform a general assessment of all API of NetBeans and Eclipse. We can see that with top 1, there are 80% of succession that match user intent. As for recall, the first person go up to 66 to 67%. Section 4. Conclusion. We have 5 results on the slide. Thanks for listening.